Greetings everyone and welcome back to the bench. If you watch my channel, you're probably wondering what's going on here. Didn't I just do a video about the issues with this amplifier? Well, after reading the comments, I felt that my video was misleading, plus I waffle on quite a bit. So I wanted to take it down and do a reshoot, maybe get some things right here. So initially I reviewed this amplifier and I thought it was a good product. And when I do a review, I don't check every single thing because, the review could go on and on. Matter of fact, if you are watching this as a review, I would recommend watching 2 or 3 different review videos to get people's different perspectives. But anyway, when I did the original review, somebody mentioned in the comments that another reviewer found a couple problems with this amplifier. One was the volume control, and another was the signal level of the XLR inputs. What they wanted to do is use both the RCA and XLR so they can use the amp with 2 different music or signal sources. And when they switch between them, the XLR signal is much too loud. The signal level is too high. So I'm going to run some tests here, and I want to add a couple of measurements that I probably should have done in the original video as well. So why use XLR inputs on a budget consumer amplifier? I think it's more of an association with professional gear. It makes this device seem more professional or elevated in its capabilities because they're using something that's commonly used on professional audio gear. XLR inputs are what's known as a balance type input. So there's 3 wires. There's a ground or shield, and there's 2 signal lines carrying the same signal but opposite in phase, 180 degrees out of phase. There's good reason for doing that in the professional environment. For example, you might be running your signals from the stage to a mixing console, and then from there off to power amplifiers. Those cables are going to be pretty long runs, and it's a noisy environment. You might have lighting and other control stuff going on. A great opportunity for noise to get into your signals. If you use unbalanced connections like the RCA, you're going to end up with a lot of noise getting into your audio. Now, using balanced input eliminates that issue because if noise enters the signal cables, it's going to get on those 2 signal lines at an equal amplitude. When it enters the amplifier, it's going to be ignored by the difference amplifier or differential amplifier that's inside the unit. So it amplifies the signal because it's 180 degrees out of phase with each other, but ignores the common signal, the signal that's common in between those 2 wires. In other words, what they call common mode noise. Now in the home environment, I just don't see a need for this. The equipment's right next to each other. There's short interconnects. To me, they could make better use of the space back here by adding more RCA inputs. You could have 3 or 4 inputs you can select. To test this amplifier, I'm going to feed in a balanced signal into the XLR input and an unbalanced signal into the RCA input, and check the levels by switching between the channels here and seeing what I get out of the amplifier. Well, I don't have a balanced signal, so I had to create one using signal coming off the Field Tech here. See that? Field Tech. Feel the quality. And I used an op amp to create a balanced signal, which comes out here, and I'm connecting it to the pins that I'm going to stick into the XLR input. I don't have an actual connector for that, so I'm just going to use these little pins that I made. So on the oscilloscope, you see we have 2 signals. On the yellow channel 1 here, and of course channel 2 is equal but opposite. In other words, 180 degrees out of phase. The amplitude of the signal, I'm just measuring channel 1, is 1 volt RMS. So both signals are 1 volt RMS. And I'll feed one of those signals into the RCA. In other words, if I turn this off, just feed the one signal into the RCA because it's unbalanced. It only can take one signal. Okay, so I connected the balanced signal to the XLR and the unbalanced to the RCA, coming off the same amplifier circuit here. The output of the amplifier is connected to the load, and I have the scope probes connected to the load. And I set an arbitrary position on the volume control to get 8 volts, close to 8 volts on the output. And it doesn't have to be 8, it could be a different voltage, but I just chose that for this test. And that's what I'm getting set to the XLR input position. So let me switch to the RCA input. And you see it dropped. It's jittering around because it's picking up some of the switching noise from the amplifier, but it drops right in half. So here's what I think is going on inside this amplifier. With the XLR inputs, like I said, you have your 1 volt signal and then your 180 degrees out of phase 1 volt signal here. Because this is a difference amplifier, you end up with 2 volts here. And of course then it goes on and gets amplified and you get more output, and the way I had it set up, it was 8 volts. Now with the RCA inputs, you're only getting a single signal, and again that's 1 volt. It goes through an amplifier with 1 gain. Both of these are gain of 1 or 0 dB, and you only get 1 volt. So what's happening is you're getting double the voltage on the XLR output. So when we switch between those, the rest of the amplifier sees a doubling of voltage, thus we get twice as much output. That's why I was getting 8 volts in the XLR setting, and it went down to 4 when I switched to the RCA inputs. Well, that seems quite normal to me, but from what I read in the comment section of the other video I took down, that's not correct. These should give you a match signal. They should attenuate the gain of this XLR input so that these are the same. And finally, what comes out of these RCA output ports, and relative to the RCA in, it's an in-phase signal that varies with the volume control. So maybe you send that signal off to a subwoofer, and it seems to be equal amplitude. Kind of getting noise into my signal there. I don't have a good setup. And about 3 o'clock in the volume control, it's equal amplitude of what I'm putting into the amplifier. Someone suggested that I should measure the gain of the amplifier. So to do that, I turn the volume control fully open, make sure the output's not clipping. Then I measure the output voltage and divide it by the input voltage, and I'm getting 18.3 times, which is 25.3 dB. That's the RCA inputs. Of course, it's going to be double that for the XLR inputs, which means plus 6 dB here. So what does that mean for the input voltage to drive it into clipping? So with the 32 volt power supply, it was clipping at 30 volts, which is 21.21 volts RMS. So to drive it to that point, I need a 1.16 volt input signal on the RCA connector and about half that on the XLR. Another complaint with the amplifier was the action of the volume control. You know, when you go from its lowest setting to where you get output, there's like a big dead zone right there. See, it jumps from no sound to a mild sound. See, the problem is this volume control has detents all the way around. It's not smooth. And it kind of jumps into those detents. So it jumps from nothing to, you know, not real quiet. You can still set it between that if you're careful, but that's kind of annoying to do. What they should have done is used a smooth action control, no detents. That way you can precisely set it. And with potentiometers, there's always going to be that landing zone. Inside there's little wiper blades, and there's always a little landing zone. That's normal to have a little dead zone before you get sound, but getting rid of those detents would have made setting this at very low volumes easier, so it just doesn't pop on. And with that, I'll wrap it up, and we'll catch you in the next one. Thanks for watching.